Hello students, so we are discussing about the chapter which is motion, and this is the third lecture after first and second part. It is the third lecture on motion. So in the first lecture we have just started and make the introduction of this chapter. In second class we did some numericals on distance and displacement and the theoretical parts of this, and also discussed about the scalar and vector terms. So if you are new in this session, you can watch that two videos. I will give the link on the description section. So today's discussion will be on speed and velocity, but before that I am just recapitulating some of the things, otherwise this class will be very boring, because if you don't know about distance and displacement, then nothing will happen about speed and velocity, right? So you should know about speed, distance and displacement at first. So I am just recapitulating. I am taking only 2 minutes to recap. Distance is what? Distance means path length. Let us consider this one is a point, this one is another point, this is a point, this is a point, and this is another point B. So from A to B we can travel by any path, by this path, by this path, by this path, by any path we can travel. The path length of this anyone means if you are moving through this path, then the path length of this one is known as distance. Okay, and what is displacement then? Displacement is the most easiest thing, means when you are going from A to B by any path, it is not dependent on path. Actually displacement depends on the initial and final position. Okay, it does not depend on path. So if A and B, these two are 2 points, initial, this one is initial. What is initial? Initial means starting point. Okay, initial means what? That is starting point. And B is what? B is final point. Final means where it stops. Actually it stops. So fact is that the distance between this starting and end or final point, which one is the minimum? Minimum will be the straight line path. Like means you can connect by any path through this path, this path, this path, but which one is the minimum distance? Which one is the shortest distance between these two? That is the straight line path. So that straight line path is known as what? Displacement. Okay, so fact is that you need to remember that displacement is always less than is equal to distance. Okay, means displacement may be equals to distance, may be equal or less than. Okay, means like you can see, if these two are 2 points, then you can go like this path, right? Like this path, through this path you can move. Now this is what? This is distance. Now displacement is simply this distance, this minimum distance from this point to this point, end to starting to end point distance. So obviously displacement is less, right? Displacement is less. So if teacher or if in your exam it is asked that when distance is equals to displacement, then what will be your answer? At the condition when the object moves along a path which is a straight line path. This is the first fact. And not only straight line path, but also the direction of motion will be in the same direction, means direction will not change. I am giving you some example, like from this point to this point you are going. Okay, so for this certain path, distance is equals to displacement. It is sure, distance is equals to how much? Displacement. Why? Because this is straight line path and starting point to end point distance is displacement. That is this is why this is the minimum path. This is why distance equals to displacement for this case, right? Starting this point, ending this point. But now fact is that if the object moves up to this at first, then is returning to this point, then what will happen? Then path is straight line path, linear path, right? Linear motion, but still distance is not equals to displacement. Let's come to the point. Let's come to a question. Like this, these 3 are 3 points, A, B, C, 3 points, Now this is 40 meter and this is 10 meter just. An object is moving along straight line path from A to C. From A to C just. From A to C it is moving. So what is the distance and what is displacement? Distance is 40 plus 10. 40 plus 10 is 50. This is distance. And what is displacement? Same thing, because the direction is same. 40 plus 10. 40 plus 10 is also 50. So distance equals to displacement. So here the path length is means the direction of motion is not changing. Direction is fixed, and with it the motion is also linear motion. Secondly, if now the particle moves at first from A to C, then to B. At first it is going to C, then returning to B, then what will happen? So for this case, A to C, now if I want to calculate the distance means the path length, just path length, it does not depend on direction. So A to C, how much distance? 40 plus 10. A to B it is 40, B to C it is 10. So how much distance from here to here? It is 40 plus 10, right? 40 plus 10 means how much? That is 50. Plus again it is returning to B. Returning to B means another 10 meter it is moving. So 10, that is 60. 60 meter is the distance. Now how much its displacement will be? So displacement will be simple. Displacement means total distance, that is 50. Along positive, if you take this positive x, then positive x direction it is moving, plus 50. And it is returning to B again. It is returning means what is happening? Now it is moving along negative x direction. So minus 10. Because displacement depends on direction. Okay, displacement is a vector quantity. So 50 and minus 10 is 40 meter. You can see still it is linear motion, but due to the change of direction, distance is not equals to displacement. So under what condition displacement equals to distance? Under the condition that the motion is linear motion and direction is same. Under this condition, distance is equals to displacement. Okay, and in all the other cases, displacement is always less than distance. This is the fact. Now let's come to our discussion, which is today's discussion. Basically this part was very much important. This is why I have again discussed today. Now speed and velocity. Let's come to the point, speed and velocity. So you know about distance, you know about displacement, right? You know about distance and displacement, these two. From distance, speed comes. From distance, speed comes. From displacement, velocity comes. Very simple thing. When you want to calculate speed of something, speed of a truck, speed of a bus, you know that at the back side of the wheel or of a truck of a wheel. So for that case, what happens? It is written that speed limit is 40 km per hour, 60 km per hour, right? Why their speed is given? Why not velocity? Because speed is general concept, that is means it is real concept. Speed is real concept which is dependent on distance. This is why. Okay, so speed is what? Speed is distance by time. Speed is what? Distance by time. Means when some distance it is traveling and it is taking some time, then do just distance divided by time. Means divide that distance with time, then you will get the speed of that object. Let us take one example. Like let's consider that a car is there. Okay, a car is moving from this point to this point. Okay, from A point to B point it is moving. How much distance it is traveling? Let's suppose 50 km. 50 km it is moving. And how much time it is taking? That is 2 hours. Okay, 2 hours time it is taking. So it is T. It is T. And distance is how much? I have said already. Distance is how much? That is 50 km. So what will be its speed? So for speed will be equals to distance by time. Distance is 50 km and time is 2 hours. So always try to write down the unit with it. Now 50 by 2 means 25 km by hour. you can see when you are doing division, you can write it down as par, right? 3 by 4 can be written like this also. Okay, this is known, this sign is known as par sign, right? Par means par 4 dozen this much of price, par 50 mangoes this much of rupees, par kg this much of rupees. Okay, so likewise in 1 hour it can move actually 25 kilometer, right? Means if in 2 hours it is moving 50 kilometer, so by unitary method in 1 hour how much it will move? 25 kilometer. In 2 hour it is 50, so in 1 hour 25. So in 1 hour 25 kilometer it is moving, so we can write it down like 25 kilometer per hour. Means in 1 hour, per hour means what? Per hour means in 1 hour it is moving 25 kilometer. Okay, so you are getting actually the kilometer per hour as the unit of speed. Okay, as the unit of speed. I am coming into the unit of speed at that point, but before that let me discuss about the velocity. Okay, what is velocity actually? Velocity is simple, what I have said already, that speed comes from distance. Similarly, velocity comes from displacement. Okay, so velocity is what? Velocity is displacement upon time. Velocity is what? Displacement upon time. And you know displacement is also known as final point minus initial point. You also know displacement means just change in position. Okay, what? Change in position. Change in position by time. Now change in position means final position minus initial position. This is known as change in position. So x final minus x initial divided by time. Rather you can say displacement means we denote it as s and time means t. So displacement by time, that is s by t. You can also say this one, right? So this is the matter. Now let's come to the unit of this too. Here we were getting kilometer per hour. Here also you will get same kind of things, because you know the unit of distance and displacement are same. So if it is meter, then you can write it down also meter. If it is in kilometer, then it will also be in kilometer. So this is the fact, means their units are same, so obviously speed and velocity unit will be same. So what are the SI units, right? What are the SI units? So SI unit of speed and velocity, because with these two are having same units. So what is the SI unit of speed and velocity? That is meter per second. How it is coming? Because distance is in the unit of meter, by time in the unit of second. So meter by second and meter per second, same things. So now CGS unit, in case of CGS, centimeter gram second. So I have already said C means C for centimeter. So length is centimeter, distance is in centimeter unit, and it is second. So centimeter per second is the unit of speed or velocity in CGS system. Also in kilometer per hour, sometimes in question may ask in that unit. So fact is that we may sometimes it is important to change the unit kilometer per hour into meter per second. So how we can change it, right? That is the unit conversion from, means if someone asks you that 1 kilometer per hour is equals to how much meter per second, can you solve this? If you can, then you can pause this video and try to find out and just match the thing with the answer. Okay, otherwise just see I am solving this. See, 1 kilometer per hour is equals to how much meter per second. So 1 kilometer per hour, 1 kilometer, I have said that per means division, right? Per means division. Now 1 kilometer means how much meter, because we are going to convert this kilometer into meter. So 1 kilometer means 1000 meter by, and 1 hour into second I am converting. So 1 hour is equals to how much second? 3600 seconds. So what I will get, that is this two, cancelling this two, I will get finally 5 by 18 meter per second. Okay, so 1 kilometer per hour, answer is 5 by 18 meter per second, and reverse is also true, means 1 meter per second is 18 by 5 kilometer per hour. Now which one is scalar quantity, which one is vector quantity, means which one depends on scalar, means direction, which one does not depend on direction actually. So basically since speed is coming from which? Speed is coming from distance, right? So this is why, since it is coming from distance, and distance is a scalar quantity, you all know distance is a scalar quantity, it does not depend on the path, okay, it does not depend on the direction. So this is why speed is also a scalar quantity, okay. Since distance is scalar, speed is coming from distance, this is why speed is a scalar quantity. Now what about velocity? You know that displacement is vector quantity and velocity is coming from displacement. This is why velocity is also a vector quantity, okay. So this is the basic fact actually. So this speed is a scalar quantity and this velocity is a vector quantity. You can note all these things in a copy, so that this will be very much helpful for you to overcome the problems, numerical problems actually. So let me discuss some numerical problems on distance, on speed, velocity, distance, displacement, all this, okay. So let's start. So this is question number 1 related to speed, velocity and displacement. What is the question? At first look into the path of this one, that an object is there and it is starting from A point, and from A point it is going to D. From A point it is going to D at first, then returning to B, okay. And during the going and coming, okay, the time is same. Means let's suppose if from B to C it is for going it is taking 4 seconds, then for returning also it will take 4 seconds, okay. So this is the fact. Now what I am saying, that from A to D it is at first going, then D to B it is returning. This is the fact, okay. So you have to find out speed, velocity, these things. Distance, displacement you need to find out for getting the speed and velocity. This is why I am not saying those terms, okay. Speed and velocity you need to find out, and you know that speed is equals to distance by time. This is why you need to find out the distance, obviously, okay. So from A to D, then to B. So at first see for distance. Distance means what? Distance means path length, okay, how much it is traveling. So from A to D, how much it is traveling? 30 plus 40 plus 20, this much meter. 30 plus 40 plus 20 is how much? 30 plus 40, 70 plus 20, 90, okay. So 90 meter. 90 meter it is going, 90 meter from A to D, plus again D to B it is returning from this point to this point. From D to B it is returning. So how much distance? 20 and 40 means 60. So 90 plus 60 meter, how much it is coming? That is 150 meter. This is distance, and we need to find out speed and velocity. We know that speed is equals to distance by time, right? Speed is equals to distance by time, and distance we already get, that is 50 meter, and time is how much? So don't confuse about the time. How much distance it is traveling means from A to D if it is going, so calculate the time for A to D, total time. If from A to D it is going, then to B, then for time also calculate the time taken from A to D, then also add that time with which one? With the time for D to B. Means if it is going from A to D, okay, add this take that time. How much time it is taking? 3, 4, 5, add this to this 3, how much you will get? That is 12 seconds. And then returning means how much time? 5 plus 4, 9. So 12 plus 9 means, this is the fact. This is how you can calculate the total time, okay. So total time means how much it is moving A to D. So for A to D, 3 seconds plus 4 seconds plus 5 seconds, then it is reaching to D. How much? That is 12 plus. Now it is returning to B, this point it is returning. So how much time? That is 5 plus 4. 5 plus 4 is how much? That is 9. So 12 plus 9. How much it is we are getting? 150 meter divided by 21 second. So you can cancel it by 3. So it will give you 7. It will give you 50. So 49 plus 1 means how much it is getting? 49 plus 1 you can write. So 49 by 7. 49 plus 1 by 7, because 50 is 49 plus 1. Now 7 plus 1 by 7 means 7 complete 1 by 7. So we are getting how much? 7 complete 1 by 7. Okay, 7 complete 1 by 7. So this is the speed, means how much it is getting, means in decimal term you can convert it, no problem. Now what about velocity? You know, velocity formula is displacement upon time. So you can calculate displacement upon time. So what is displacement? So displacement is nothing but the distance from initial to final point, right? Shortest distance between, means if this one is initial point, this one is final point, this two, then just join this with a line, with a straight line, calculate the length of this line, this will give you the displacement. Okay, so here what is the initial point? Initial means starting point A, and via it is coming to B. Via it is not necessary. Why it is not necessary? Because displacement does not depends on path. Means it is going at first to C, then to B it is coming, or it is going to D, then coming to B. It does not depend on that parameter. It depends only on initial and final position. Okay, like initially it is A and finally it is B. Only take these 2 points and connect these two points via a straight line. It is already connected, and this distance you can see that it is 30 meter. Then displacement will also be 30 meter. It's a very simple thing. Means distance, the separation between initial and final point, that is 30 meters. Simple. And the time we have already calculated. The time means now the students may be confused about the time, that how much time we should take, this 3 seconds or total. So for that reason you have to see that where from it is coming, right? Means it is at first going to D, then it is returning to B. Okay, means time means total time. Okay, total time how? Means at first A to D it is going. A to D is 12. A to D is how much? That is 12 second, plus this 5 plus 4 means 9 second. Why why I am doing this kind of things? You may ask me the question that why I am doing this kind of things. Just see the basics. What about the basic of displacement? Right? What about the basic of displacement? Basic of displacement is, it depends on direction. Now when it is going right hand side, means it is going to D, from A to D. If I take it positive x axis, then it is moving along positive direction, so value is positive. Means 30 plus 40 plus 20, that is 90 meter I am getting. This is 90 meter along positive x direction. Now when it is returning, then for that path it is along negative x direction. Negative x direction means we have to subtract the thing. Means along negative x direction it is moving how much? 20 and 40 means 60 meter it is moving. So 90 meter minus 60 meter. Now you can feel that why I am taking a whole the time instead of 3 seconds, right? What is the fact? I have taken this one 90 meter. 90 meter from A to D. So what is the time for that? Time is 12 seconds. And I am adding this term with negative 60 meter. Negative sign I am using just to show the direction. Nothing but just to show the direction. Okay. So for that one also some time will take na. For 60 meter it is returning, it's fine. But some time will be taken by that thing. So this is why how much time it is taking to return, that is 5 seconds plus 4 seconds means 9 seconds. So 12 seconds plus 9 seconds. How much I am getting? So above at the numerator it will be 30 meter divided by 21 second. And this will give you 10 by 7. 10 by 7 meter per second. 10 by 7 means how much? That is 1 complete 3 by 7. 1 complete 3 by 7 meter per second. So this is how you can easily calculate the, so this is basically velocity. Velocity means displacement by time. So this is how you can calculate distance, displacement, speed, velocity. Means if you have a better concept of distance and displacement, then you can easily solve the problems from velocity and speed. Okay, just need to remember that when you are calculating velocity, you need to see means initial and final point for displacement, and total time you have to calculate total time for the whole path. Okay, means only if you are taking this 3 seconds for this path, then it will be wrong. Okay, so you need to remember on these two things. Now in the last class, in part 2, motion chapter part 2, you can see the on the playlist also. There we have discussed on a lot of problems on this distance and displacements. Okay, circular motion along a triangle, if it moves, this kind of problems we have already discussed. So you can go and further check the details, because if you have the deep idea about distance and displacement, then you can easily solve the problems from velocity and time, velocity and speed. Okay, so this is the basic fact. Okay, for this video up to this, in the next class I will try to solve some numerical problems again, and we'll discuss also on acceleration. Acceleration is very much important thing. So okay, for this video, thank you.